Welcome to the section of this e-learning module on weed control in a horticultural setting. I'm Matt Smee, the Head of Agroecology at the Organic Research Centre.
And I'm Ella Bradfield, Research Scientist at ADAS.
In the context of horticulture, few challenges are as persistent and economically significant as weed management. Weeds compete directly with crops for critical resources such as light, water, nutrients and space. Their unchecked proliferation can lead to reduced yields, increased production costs and compromise crop quality. Moreover, certain weed species serve as alternate hosts for pests and diseases, further complicating management strategies. Effective weed control, therefore, is not simply a matter of maintaining aesthetic standards or meeting market expectations. It is foundational to crop health, productivity and long-term system sustainability. I'd like to begin by framing weed management not as a reactive task, but as a strategic component of sound horticultural practice. Specifically, this section will highlight the importance of physical control, strategies for targeted chemical application, and finally, cultural controls with the integration of agroecological techniques. Complementary approaches that, when applied thoughtfully, offer both immediate and long-term benefits. Physical control refers to the mechanical or manual removal of weeds. While often labour-intensive, these methods include hand weeding, hoeing, mowing, flaming and tillage. They're particularly valuable in settings where chemical control is either undesirable or restricted, such as in organic systems or high-value specialty crops. Physical methods offer immediacy and precision, making them essential during early crop establishment or in tightly spaced plantings. However, their effectiveness can be limited by scale, cost and labour availability. This highlights the need to complement them with preventative strategies.
Chemical control is an important aspect for weed management in horticulture. The number of available herbicide options is often limited in horticulture as fewer products are developed for minor crops. Herbicide resistance issues can also have an effect on product efficacy, so this must be considered. There are exciting advances in application technology for chemical control, including targeted spot spraying and drone spraying, now becoming more popular. For a good integrated weed management approach, chemical control can be complemented by a range of physical and cultural control techniques. Cultural control involves adjusting horticultural practices to suppress weed emergence and growth. This includes practices such as crop rotation, planting density, cover cropping, the use of diverse rotations, and optimising sowing and harvest times. For example, high-density plantings or fast-growing cover crops can shade the soil surface and reduce opportunities for weed seed germination. These techniques create conditions that favour crop development while systematically reducing the ecological niches available to weeds. Finally, agroecological weed management takes a systems-based approach by integrating ecological principles into horticultural decision-making. This involves designing cropping systems that enhance biodiversity, support soil health, and disrupt weed life cycles naturally. Examples include intercropping to increase ground coverage, using allelopathic species to suppress weed germination, and maintaining habitat for beneficial organisms that indirectly contribute to weed suppression. Agroecological practices aim not just to manage weeds, but to understand and address the underlying factors that contribute to their success in a given system. In summary, sustainable weed management requires a multifaceted approach, one that incorporates both immediate interventions and longer-term ecological strategies. By combining physical and cultural controls with agroecological thinking, we move beyond symptom management toward a more integrated and resilient model of horticultural production. Across this segment of the e-learning module, we will examine each of these approaches in greater detail, supported by examples and work from the Oper8 project to explore how their integration can lead to more effective and environmentally responsible weed management.